The purpose of this slide is to derive the famous formula for the solution of the general quadratic equation. If you have seen this formula before, I hope this will be a good refresher of the theory. And if this is the first time that you're seeing the formula, please bear with me. So, how do we solve a general quadratic equation ax squared plus bx plus c equals 0? Think of an equation like this one. 2x squared, say minus 3x, say minus 7 equal to 0. So something like that. An arbitrary quadratic, set it equal to 0. How do we solve such an equation? The first thing we do when we solve a quadratic equation is we complete the square. Now, in the preceding discussion, we studied in great detail how to complete the square. So I'm going to directly produce the answer for you. We complete the square to get that ax squared plus bx plus c is equal to a times x plus b over 2a, the whole thing squared, minus d over 4a, where d was the discriminant. The discriminant was equal to b squared minus 4ac. So that magic number d is equal to b squared minus 4ac. All other letters that you see, a and b, they are the original a and b from the original quadratic equation. Okay. So this is how we complete the square. This is actually most of the work. But let's see what we can do with this expression. The next thing we do is we identify a, and we factor out a from the constant term. Now see, a is factored out of the quadratic term, but it is not factored out of this constant term. So what we do is we factor a out of the constant term as well. Now when you factor a out of a term which does not contain a in the numerator, you have to divide by a. So this a, when we factor it out of d over 4a, it becomes a squared. So a times a squared, so the product of the a divided by a squared, so the quotient of these two terms is equal to 1 over a, this term here. So we have factored out a. Okay, so we factored out a. What will we do next? The next thing we're going to do is we're going to take the term that you see here, d over 4a squared. So we're going to take that term and we're going to transform it into a square. How can we do that? So I'm taking that term that we see here, d over 4a squared, and I'm transforming it to this term here. So that guy has been transformed to this one. So what have I done here? First, I have taken the expression d and I have transformed it to radical of d squared, right? So I can write that radical of d, the whole thing squared, equals d. So that's what I've done there. And I have transformed 4a squared. I have rewritten 4a squared, this 4a squared, as 2a, the whole thing squared, right? So 2a, the whole thing squared, right? So 2a, the whole thing squared, that is 2 squared times a squared, which is 4 times a squared, which is exactly this 4a squared. So that's what I've done there. So just a reminder, we always need to be careful when dealing with radicals and squares. So just a reminder, if I take radical of d squared, that is not necessarily equal to d, that is equal to plus or minus d, depending on whether d is positive or negative. But when the operations are in the opposite direction, so when I have radical of d, the whole thing squared, then I always get d out. A reminder, this actually works for negative d as well. Radical of a negative number, that would be a complex imaginary number. So that is actually okay. So here, in case d is negative, by radical of d, I mean the complex number, radical of negative something. Okay. So what we have done so far is we have transformed the constant term into a perfect square. Why on earth would we want to do that? Well, here's the trick. By transforming the constant term to a perfect square, we have arranged that what we see in here, the expression here, is a difference of two squares. So here we're having something squared, x plus b over 2a, the whole thing squared. And here again we're having a different expression squared. So we have arranged that the expression that we see here under the parentheses is a difference of two squares. But how does that help? Well, let's see. We know that when we have a difference of two squares, so if I have a difference of two squares, I can factor that. How? Well, if I have a squared minus b squared, that's exactly what I'm having here. This expression here, I can call it a, and the whole thing becomes a squared. And this expression here, I can call it b, and then this whole expression here becomes b squared. So I'm having a squared minus b squared. That's what I'm having. And I remember that a squared minus b squared can be factored as a minus b times a plus b. So this expression that I see here, a squared minus b squared, can be factored. And how does it factor? Well, when we are factoring a squared minus b squared, we get a minus b, so that guy here plays the role of a. That is my a. That is a. That is a. And that expression here, plays the role of b. So that is my b here. And that's my b. And this was my a. There we go. That is my a. So you can see a squared minus b squared is equal to a minus b times a plus b. So we're now in a very good shape. We have successfully factored our quadratic. Now, a factored equation is very easy to solve because see, what have we achieved? We have the product of three quantities, which is 0, right? So we have the quantity a, this second quantity and this third quantity, and the product of those three quantities is 0. But how could the product of three numbers be 0? Well, for the product of three numbers to be 0, at least one of those three numbers has got to be 0. We could also have the case that two of them are 0, or we could have all three of them be 0, but at least one of them has got to be 0. If they're all non-zero, that doesn't work. So there are three options. Either this a must be 0, but that's not the case because a is not equal to 0. When we write down on a quadratic equation, it is always implicitly assumed that a is not equal to 0. So that was an assumption from the beginning, else we wouldn't have been calling this equation a quadratic equation. So a is not 0. So our only chance of having then 0 is to have that either this term, x plus b over 2a minus radical of d over 2a. So either this term is 0, or the next term, x plus b over 2a plus radical of d over 2a. So that term here must be 0. So one of the two must be 0. Once again, either this term, x plus b over 2a plus radical of d over 2a must be 0, or x plus b over 2a minus radical of d over 2a must be 0. One of the two must hold. We're almost done. All that remains is to solve. Now we've got two linear equations in x, the left hand one, this one, and the right hand one, and we can immediately solve for x. Let's do that. So I'm solving now this equation for x. I'm taking plus b over 2a and I'm transferring it from the left-hand side to the right-hand side. The minus becomes a plus, and b over 2a becomes minus b over 2a. And I also need to transfer radical of d over 2a to the right-hand side. The minus here becomes a plus. And finally, I can take those two terms. They have a common denominator. Both of them are divided by 2a. So since they have a common denominator, I can put them under a common denominator, which I have done here. So I have put the terms under the common denominator, and there we go. I have solved for x. So x is minus b plus radical of d over 2a. That's my first option. And my second option, for my second possible equation, I can transfer plus b over 2a to the right-hand side. The plus becomes a minus. And I can also transfer radical of d over 2a to the right-hand side. The plus becomes a minus. And I could put the two fractions on the common denominator. They already have a common denominator, so I can combine them to a single fraction. And there it is. There is our solution. So x equals minus b plus radical of d over 2a. So x equals minus b plus radical of d over 2a, or x equals minus b minus radical of d over 2a. Our solution is complete. So let's recap. We started with the general quadratic equation ax squared plus bx plus c equals 0, and we got our two solutions. X equals minus b plus radical of d over 2a, or x equals minus b minus radical of d over 2a. Now, I'm going to remove all of the derivation that we did so far. So I'm going to remove that, and I want us to just stare for a while at the general quadratic equation and its solution. Okay? And now I'm going to take that and I'm going to transfer it to the next slide, and I want to organize our solution into a theorem which we need to memorize. So now I'm going to take that solution and I'm going to transfer it to the next slide. There we go. So I have my general quadratic equation, ax squared plus bx plus c equals 0. And its solutions were given by x equals minus b plus radical of d over 2a, or x equals minus b minus radical of d over 2a. Just a reminder that magical d was b squared minus 4ac. So that magical letter d was called the discriminant. So this was the discriminant. Let me remind you, d is the discriminant. It discriminates between the two roots of the quadratic equation. So that's the discriminant of our quadratic, and it is given by the formula b squared minus 4ac. Okay, so that is our solution. And now there are two possible solutions. So what's the difference between those two solutions? Well, one of the solutions has a plus in there, and the other solution has a minus. Now, I want to do something. I want to introduce names for these two solutions. So the solution that has the plus in it, I'm going to call it x1. So I'm going to call this number, the number that we see here, I'm going to call it x1. And the number that we see here, I'm going to call it x2. So I'm introducing two numbers, x1 and x2. These are the two solutions. One is with the plus and the other one is with a minus. And finally, using that, I'm able to formulate a somewhat shorter version of this formula. So here it is. The solution of the quadratic equation ax squared plus bx plus c equals 0, so the solution of this quadratic equation, is given by the following formula. Its two solutions, x1 and x2, are given by the formula. So the two solutions, x1 and x2, are given by the formula minus b plus or minus, so this symbol here is read plus, or minus, because that's what we had on the previous slide. So plus or minus radical of b squared minus 4ac, or radical of d, radical of the discriminant, the whole thing divided by 2a. So that is our final formula for the solution of the quadratic equation. ax squared plus bx plus c equals 0 is solved by, its two solutions are given by x1 and x2 equal to minus b plus or minus radical of b squared minus 4ac over 2a. I want you to memorize this formula. If you haven't memorized this formula so far, please do so. Memorize this formula by heart. You will be using this formula a lot in the coming, in the remainder of this session.